On the screen you can see I've opened an editor and I'm looking at a file called file2append.txt, and within the file we have these two lines of code. I am the first line of text, I am the second line of text. Now earlier in this playlist you had a look at this computer program which is responsible for appending another line to the text file. This first program statement creates a variable called data and fills it with the text I am a line to be appended to the file. This will open the said file in append mode, and this here will write the data to the file, and then we have to close the file to release resources and to close the stream that was created between the Python program and the text file. Now I've reminded you of this program simply because I wanted to repeat the fact that when you're dealing with files, you have to open them as shown on this line, and then you of course will always have to close the file. So the opening and closing is fundamental to the accessing of text files in Python. Now the program I'm going to move on to is going to show you an approach that means that you don't have to issue this program statement and as the programmer be responsible for closing the file. We're going to use another statement referred to as a context manager, which in the case of the code I'm going to show you in this video, it's going to be using the with statement. Before we look at the with statement, let's be quite clear as to what this computer program has done. If we look at the file that we're accessing before the program was executed, you can see it here. And remember, it had these two lines in. Now, after this program executes, what you will see when you look in the editor is this. And you can see that it has got this additional line, I am a line to be appended to the file, which was taken from here, and was wrote to the file on this line using the write method where we pass the data in, where clearly the data was the data set up on this line here. So we're looking at before the program runs, and we're looking at after the program has run. Now let's compare this computer program with the one that's floating into view. Now, in terms of what they do exactly the same thing. They will open a file, they will append data to the end of the file, and then they will close the file, but they do them differently. Let's have a look what they have in common. We can see they both set up the same data, they both use the same open, and they both write to the file. But if you have a look at this program, you can see we have to close the file, whereas if you look at this program, there is no closing of the file at all. Now that's because we use this statement here, which is the with statement. Let me remind you, starts with the word with, has this word as, and also has this colon here. And in this position, we're setting the context for this with statement, and the context is file access. So this with statement knows that it's opened the file. This is the block inside the with that is actioned, and the action is to write data to the file. But because the with is aware that it's dealing with a file, and it knows that it has opened a file, it knows to close the file. So it takes care of the closing of the file for us. So as a computer programmer, we don't have to write a line of code to close the file and free the resources. It's done automatically by this statement here, which is an example of a context manager. So you can think of it as being behind the scenes. It is effectively doing the same as this statement does for this computer program. Now, how it does this, at this stage, I'm not going to consider. Just accept that it will perform this task, and we can look at what are called dunder methods, which are the underlying mechanism that allows this context manager to function. For an understanding of how we can actually append to a file using the with, this program should suffice. And we can see we open it, we don't have to close it because it will close the file for us. To ensure we know how this computer program works, let's reflect its execution onto an appropriate schematic diagram. The diagram is coming into view now, and what we can see is that this Python code is represented here in the schematic diagram. We know we have the operating system with a relationship to this file, file2append.txt, which is the file shown here in the program code. This is the first line to execute, and I'm going to show that on the schematic diagram with this that's just appeared. And this is saying I am a line, and I've got those 3 dots because this is representing this text here that appears as a string within the computer program. This is the next program statement to execute, and what it will produce is a stream between the Python code and the file called file2append.txt. And I'm going to show that appearing in the schematic diagram now. If you keep an eye on the schematic diagram, you will see that a label is coming into view, and this label is my file. So the stream has this name, my file, which is the object reference to the stream. It's saying where the stream is. Now, why my file? Well, because if you look here, that's what I used in the program code, my file. So what this line has done, it's opened this file for appending, and it has called the file stream that's created, the object created, my file. So if I turn our attention now to the schematic diagram again, we can see that this is in fact an object. It's an instance of a class. If I now move on to this program statement, we can see that it is referring to the stream my file, and we're going to be invoking the write method because remember the stream is in fact an object, so this is going to be a method of that object, and you know the write is taking as an argument the data, and that's the data that appeared on this line. So when this program statement executes, what's going to happen is the data that was in the variable that I called data, in other words, the string I am a line to be appended to the file, is sent via the stream to the file. Now, this is the only program statement that is within the with block, and this was the code block within with. And because the with statement has now finished its execution, because there is nothing else within the code block, remember, because it is a context manager and it has been responsible for opening the file, the with statement, i.e. the context manager, knows it has to close the file. Consequently, when we have finished executing this, we've finished with the with, and the stream will be removed together with all of its resources. So when the with ends, keep your eye on the schematic diagram and you will note that the stream is now removed. So the Python code does not have a link with the file2append.txt now. It's performed its task, it's appended to the end of the file, and now the link has been removed. So if we look to this with, we know it was responsible for opening with this, and because it's the with statement and it's a context manager, it's saying, oh, I've been dealing with files. I better shut down the stream and release the resources. So that's what it does. So we don't have to put the close in ourselves as the computer programmer. So let's consider the file, the text file, before we executed this program, and you can see that coming into view here. Now, if we execute the program, what you're going to see in this file is what's coming into view. And you can see that this string has been appended to the end of the file. We're looking at the before and after.